Hong Kong scientists have developed an artificial intelligence model that could pave the way for faster and more effective fertility treatments. Researchers from the University of Hong Kong said the AI model can detect fertile sperm with a 96% accuracy. Professor William Yeung at HKU's Clinical Medicine School is in our studio to tell us more about this new innovation and what it could mean for the future. So, Professor, thank you so much for joining us in the studio. Could you first tell us how this AI model works and how it's different from traditional models?
So our models is basically a method using artificial intelligence or AI to identify the sperms with fertilizing abilities based on their morphologies. So in an ejaculate, even in a fertile man, or the ejaculate contains about 100 to 200 million sperms. But only about 7% of them have the fertilization abilities. Therefore, our model is basically to identify this particular population of sperms. How we do that is we try to identify the sperms that bind onto the outer coat of an egg. So to be more specific, all human eggs are covered on the outside by a non-cellular matrix. We call it the zona pellucidus. If the sperms wants to fertilize an egg, the sperm has to bind to the zona pellucidus, and then they digest part of the zona pellucidus and penetrate the zona pellucidus before they can fertilize the egg. So that means those sperms that can bind onto the zona pellucidus firmly are those that have started fertilizations. And in fact, in the literature, there are evidence showing that those that bound onto the zona pellucidus are those having fertilization ability, and their fertilization rate can be increased if there are more of these sperms. So our model is basically to identify the morphology of the sperm on the zona pellucidus and compare with other sperms that cannot bind onto the zona pellucidus. In our model, we have put in over 1,000 of sperm images and try to compare these two groups of sperms. And our accuracy is pretty high, it's over 96%. So the model basically is to identify the percentage of this particular population of sperm in a sample. So the higher the percentage, the more likely that the samples can fertilize the egg. That is the basic rationale. So in how is our models different from the traditional methods? Now, there are two differences. The traditional methods is based on the morphologies criteria recommended by the World Health Organization, WHO. So the morphologies criteria based on this WHO comes from the sperm populations that are in the cervical mucus of the women. So these are the sperms, not yet fertilized the egg, but just about to enter the uterine cavities. So they are very early portion of the sperms consisting of both fertilization competent sperm and non-competent sperms. And the other difference between our models and the traditional method is the traditional methods use technicians manually to count the number of normal sperm according to the WHO criteria. Now, as you know, that these are very subjective determination based on the subjective judgment of the technician. So there is a lot of variations between technicians. And also even with the same technician, if you give the same sample for them to count 2 times, there could be differences. So, and therefore, their variation is high, whereas in our model, we use computer to count. So it's objective, without bias, and it's more stable.
So in terms of applications, how would this tool help assisted sort of reproductive procedures like IVF?
Okay, now we can help IVF in two ways. One is to make a diagnosis. Our diagnosis should be more accurate. As I have told you, that our methods is to base on the morphology of the sperms that can fertilize the eggs. So in a way, our parameter is related to the function of the sperm in fertilization. Whereas in the WHO one, it is based on a mixture of sperms. So from that point of view, WHO cannot be 100% perfect, okay? Because they have fertilization incompetent sperm mix in the populations. And also, the technicians, the manual countings would cause a lot of variations. So in terms of diagnosis, I think our models will be more accurate in determining whether a sperm sample have fertilization capacities. Now, the other way to help infertility is we can avoid fertilization failure in conventional in vitro fertilizations. Now, in conventional in vitro fertilizations, inseminations, we just mix the sperm and the egg together and allow the sperm to fertilize the egg. In the IVF program, we encounter patients whose semen, whose sperm parameters are perfectly normal according to the WHO criteria. But some of them, they have fertilization failure or reduced fertilization in conventional IVF. So our methods, our data also show that our methods can identify this particular group of men with normal semen parameter but with fertilization problems. So this group of men, in the literature, it varies from about 5% to 25%. In our clinics, it's about 3 to 6%. So for men, if they have undergo IVF, they have fertilization failure, then they have no other choice but to start another cycle because they just do not have embryo for replacements.
Mm-hmm. Well, how big of a problem is infertility in Hong Kong?
In Hong Kong, our infertility problem is about 1 in 6 couples. It's likely higher in China, it's about 1 in 5. And among these couples coming for assisted reproductions, about half of them, from the data in Hong Kong, about half of them are male factors. And about another 10% is what we call it an unexplained factor. That is, we don't know whether it's a male or female. I suppose there will be also some male factors inside this group. So basically, I would say 50 to 60% of the men undergoing IVF would have their male factor problems.
In terms of what comes next after this research, how soon or how likely is it that we will be able to implement this tool across clinics in Hong Kong?
What we are doing now is our next step is to do a clinical trial to clinically validate these methods for clinical use. And the next step will be to develop even better methods. The better methods is to use living sperms to identify them when the sperm are even alive, they can swim. So this this project is in collaborations with the Inno Hong Kong Advanced Biomedical Instrumentation Centers. And they have special techniques that can identify the living sperms, and they also have techniques, patent technologies to separate them. At the moment, this method is applied in University of Hong Kong Queen Mary Hospitals, Gong Hwa Hospitals, as well as our hospital in Shenzhen. So basically, because we are doing a clinical trial, so the patients joining our trial will be able to use these technologies. And after that, this technology will be spread to across the Hong Kong as well as in the Greater Bay Area.
Wonderful. All right. Well, thank you very much, Professor Yeung. To read more about this research, visit scmp.com.